All right, this is Chapter 3, Lesson 6, and Modeling Direct Variation. This should be interesting. All right, direct variation. So here's what the first thing I want to tell you, the key concept for your notes. Okay, two variables, which we've been working with, x and y. They show direct variation provided y equals a times x and x does not equal 0. And it says, in other words, they vary directly, and that doesn't mean a whole lot. But I want you to look at this y equals a times x, just like what we've been talking about, where a is your slope versus m. Any number or letter that represents a number in front of your x is always going to be your slope. So as we look at this equation, here we go. The non-zero number a is called the constant of variation. It's like the rate of change. It's your m. It's your slope. And y is said to vary directly with x. In other words, it's a constant rate of change. Okay? And in other words, it's an equation in slope-intercept form where the y-intercept is 0. So it kind of looks like this. Y equals, and we're going to use the a because that's what they put for the direct variation, a times x plus 0. So that's why there's nothing really out there to the side, because when you have a y-intercept that's 0, it's like a plus 0. So a direct variation equation will have a y-intercept of 0, so there will never be a plus b. If there is a plus b, if there is a y-intercept other than 0, it is not a direct variation. Okay? And a direct variation graph must begin at the origin, because if your y-intercept is 0, that is where you start. So in other words, when x is 0, y is 0, and that makes a direct variation. It's a constant rate of change. So think back to like our toilet flushes we did on that worksheet the other day. Our toilet flushes, they were direct variations. The more flushes you did, the more water you used. And if you had 0 flushes, you used 0 water. That was an example of a direct variation graph. Okay, and here's another example. Y equals 5x. The constant of variation, okay, you can underline that or fill it in if you're on your notes. I'm not sure if that's blank. But you can also, the constant of variation is also your slope. So sometimes you might hear that on a direct variation equation. Instead of slope, you might hear it called constant of variation. All right, so let's tell whether the equation represents a direct variation or not. And if it does represent a direct variation, we're going to identify the constant of variation, or the slope. Okay, so the first one that's being shown is 2x minus 3y equals 0. So let's rewrite this with y as a function of x. In other words, we're going to solve for y. And we're going to try to rewrite it in this form. So as we solve for y, if it ends up in this form with no y-intercept, then it's a direct variation. So just so we notice, we're going to subtract 2x from both sides, and we get negative 3y equals negative 2x. And you can already tell, since there's no constant out here to add or subtract from our x term, we know we're going to have a direct variation. So divide both sides by negative 3, and that's how we end up with the 2/3 x. So it is a direct variation just because it's like a plus 0 out here, or nothing. So this is a direct variation with a constant of variation being 2/3. Okay, so pretty simple. So let's do another example. So this time we have negative x plus y equals 4. Right here is a tell that might possibly mean it's not going to be a constant of variation, or excuse me, a direct variation. It may not be. We have a constant right there instead of a 0. So let's just solve for y and see what happens. So since we have a negative x, we need to add an x to both sides so that our negative x and positive x add to 0. And so we end up with y equals x plus 4. So do we have this equation? Is it in the form y equals ax? And we can look at it and we say no, because our y-intercept is what? A positive 4. So is this graph going to start at the origin? It is not. Our y-intercept is something besides 0. So it does not represent a direct variation. And since it doesn't, there's no constant of variation. There is a slope. The slope is 1. Okay, that slope is the understood 1. But there's no constant of variation because it's not a direct variation. Okay? So, moving on to example 2, we are now going to graph a direct variation equation. So, here is my equation. It's the one we solved for first in example 1. And why does it show a direct variation? Because the y-intercept is 0. Our b is 0. It's a plus 0. So our b is 0. So that means we're going to be starting at the origin. So since our y-intercept is 0, we start at 0, 0. And then we just use our slope of up 2 and to the right 3. So we go up 2 to the right 3, graph our point, and we create our line. So it's not really anything different. The only thing different about direct variation equations is it's going to always pass through the origin because our y-intercept is always 0. Okay? All right, so we're going to graph this one. Obviously, our y-intercept is 0. So we're going to plot our point at the origin because our y-intercept is 0. This time, our slope is negative 3 over positive 1. So we're going to go down 3 and to the right 1. Negative is down, positive is to the right. So down negative 3 to the right 1, graph our other point, and we're going to draw our line. Okay? Notice what our point is. Positive 1, negative 3. Positive 1 on the x, negative 3 on the y, because our slope is always change in y over change in x. Interesting. Okay. All right, the graph of a direct variation equation is shown. We know that because it passes through the origin. So it may be a negative variation. That's fine. It can be a negative direct variation as long as it passes through the origin. And we are going to write it. So write the direct variation equation. So I need to know what my slope is. Okay, since the y-intercept is 0, start at the point 0, 0, and count up and over to find your slope or your a. So we go up 2, so it's a positive 2 that we go up, and then we go to the left 1, which is a negative 1. So my slope is 2, positive 2, over negative 1. Okay, so my slope is negative 2 over positive 1. So my y equals my a, or my slope, times x. So there's my equation. Notice my slope of negative 2 over positive 1 is very similar to my y-coordinate, positive 2, over my x-coordinate, negative 1. That's a hint. When you're graphing a direct variation equation, you can see that it passes through the origin. Your slope is going to be your y-coordinate over your x-coordinate of a point on that line. Any point. Because if it's a different point, it could reduce. If we go up here to this point, okay, this point is negative 2, positive 4. So if we take my y, put it on the top, 4, okay, over negative 2. Sorry, I wrote this down here wrong. It doesn't matter, it's still a negative slope, but I wrote my negative, I'm sorry, with the 2. I apologize. The negative should be with the 1. The negative should be with the 1. Just to keep it like the point, positive 2, negative 1, positive 2, negative 1. It's still just a negative 2x. Okay? I did go up 2 to the left 1, so I should have done it that way. All right, so my slope technically is this. Okay. All right, but I want you to see this. Up 4, left 2, that reduces still to a negative 2, or a positive 2 over negative 1, however you want to look at it. Okay? All right, so there's my a, or my slope. We discovered that negative 2 is the a, or the slope, and it's the number in front of x, and we've already written the equation. So there's my direct variation equation. Y equals negative 2x, which is the same thing as what we decided, even the positive 2 over negative 1. Just so you know, these are the same thing. Okay? All right. Now we're going to find the value of y when x equals 30. So we're going to use this equation, and obviously we're going to substitute in. When x equals 30, y would equal negative 2 times 30, so y would equal negative 60. Just substitution. You might have some of that in your assignment. All right, example 4. Tell whether the tables, or the tables, there's plural, represent direct variations. If so, write the direct variation equation. So here's my first table. So I want you to look at the change in x and the change in y. And remember, we always do change in y over change in x. So let's look at how these are changing. So my x values are, well, plus 1, plus 1. We see a pattern. But wait, it jumps right here to plus 2. So let's look at my change in y. We go plus 5, plus 5, plus 5. Well, we double here, but we also double here. So that's okay. So my rate of change is change in y over change in x. So my a, or my slope, is 5 over 1. Now, let's go backwards and let's subtract 1, because we don't have where x is 0, because to be a direct variation, it has to pass through the origin. It has to pass through 0, 0. So when x is 0, let's see if y is 0. So if we subtract 1 to 0, down here, since we're increasing by 5, we would subtract 5, and we would get 0, 0. Does that make sense? Okay. If not, circle that, and you can ask questions, and we can talk about it. Okay. But going backwards to see where x is 0, we need to see if y is 0. And if they are 0, 0, if it does pass through the origin, it's a direct variation with this as my a. So the equation, direct variation, because when x equals 0, y equals 0, and we see the pattern in the x and y values. We see a constant rate of change. So my equation would be y equals 5x. My y-intercept is 0, so that's why there's no plus b. And that's why it's a direct variation. Okay, next table. Let's look at my change in patterns here. I can look at a change in patterns. I do plus 2, and then I do plus 1, and then plus 1, plus 3 for my y. And then here I do plus 2, plus 1, plus 1, plus 3. So my rate of change is, at least when it's plus 2 here, it's plus 2 here. It's a constant rate of change, because if I put y over x, every time it simplifies to 1. But when I look when x is 0, right here, when x is 0, my y is 5. So this is not going to pass through the origin. It's going to pass through y, the y-axis, at positive 5, not at the origin. So it's not a direct variation, because although there is a pattern in our values, we have a constant rate of change, we do not pass through the origin. Okay, you can stop the video and do the guided practice. It's pretty easy. Just tell whether it's a direct variation and then graph one of them.